Okay, as I already sent this picture to all your mails, it is just an module which consists of 8 inputs and 1 output. Is simply an 8-bit 8 input adder. So the inputs for this are, let us suppose take A to H, and each are 8-bit inputs. So we have considered an off adders for addition. So we require totally of 7 off adders. Each off adder consists of 2 inputs, and the purpose of this off adder is to add these 2 inputs and get 1 output. Along with this image in the mail, I have already sent the code which is the first idea implemented as simply as butterfly. We have written the code for each 7 modules, off adder 1, off adder 2, so on to off adder 7 separately, because each off adder has different input and output parameters. Suppose let us consider these row inputs. It consists of inputs of 7 down to 0 and outputs as 8 down to 0. For this off adder 5 and 6, the inputs for them are 8 down to 0 and the output is 9 down to 0. And the output for the final off adder, the input is 9 down to 0 and the output is 10 down to 0. So for each off adder, the parameters is going to differ. That is the number of bits as inputs and outputs. So we have defined 7 modules, off adder 1 to off adder 7. Okay, I will show you the code. So this is off adder project something. In this we have to maintain 3 folders: RTL, SIM and TD, and we have to design all this in RTL. So I have made off adder 1, off adder 2, off adder 3, off adder 4, so on to off adder 7. Let's look this. Okay, some module name, the parameter inputs, so wires, declaring the input and output ports along with their inputs capacities, and finally assigning and module. This is for something off adder 1. Let us look at the off adder 5. So these inputs are default, so I have shown this, and the parameters of inputs and outputs are similar as shown in the figure. Given inputs x1, x2, we have implemented based on this figure only. Okay, similarly for off adder 7. Okay, after completion of this, we have to instantiate all these 7 off adders. So if you look at this code, this module name and the input and output ports, port names. So here we have implemented as it is, but there is some mistakes here. Let us correct all this. We should not use a numeric number as the starting letter. So it should be, and we should not also use the special characters. We can use either underscore or a dot. Not dot, underscore is preferable. So input 8 under bit something, it should be better for better understanding. So, and we also made a mistake here in the last class. Okay, and we have to declare the port input and output ports. These are the intermediate ports, and these are the intermediate connections during instantiation. Similar to the butterfly module, you have developed these simple steps of each module and their internal connection to which for the which port which is connected. You have written an end module, and the interconnection wires are to be declared before. These are the interconnection ports, so I have to declare like this. This is the basic simple idea which we have implemented. But seeing the image, an interesting thing has happened, because we have written the code for 7 modules. So it's very it's very difficult of typing all these 7 modules. So what we have to done is, we have to write one module. We have to write either only one module, and you have to repeat it 7 times. You have to repeat during instantiation 7 times. What is the difference for this operator and this operator? Only the inputs ports, so only the parameter. So we have to consider only the parameter change, and we have to declare it during the instantiation, and you have to implement. So let's look at this implementation and its simulation also today in this video. Okay, these are the half adders and these are the half adders. Let's look at the modified code. So we have to declare only one code, and I am declaring the name as off adder 8. Note that this off adder 8, note that the module name, here we are using the module adder under 2 input. Okay, the module name and the and this file to be saved under the same name. I mean this adder under 2 module name should be matched with the Verilog file which you have to be saved. Okay, module name, and as we consider it has 7 off adders. So each off adder, let us consider inputs as X and Y, and the output as O. Okay, for all the 7 off adders, and you have to declare that only the parameter changes, only the parameter change for the 7 off adders. So we have to declare during the instantiation. So for that we have to use this command, parameter something dwidth is equal to 8, because why we have chosen dwidth is as 8 means, let us look at this first column of it consists of 4 off adders, and the inputs for it are same, and the output for it is 8 down to 0, and input is 7 down to 0. So if you consider the dwidth as 8, it is simple, so that we can do the program for 4 without any modification during instantiation. Okay, it will be better idea during instantiation. It will give a clear idea regarding it. Okay, we have to declare a parameter. So parameter is the keyword, and we have to use any word like dwidth. We have used something. The width is to be changed, so we have to with data width something is equal to 8, and here declare the input wires X, Y, 0 into the wire declaration, and you have to assign O is equal to X. As all the off adders are the same function, we have to use this command, assign also an end module. And the thing which you have to be chosen is you have declared d width as 8. So let us look at this half adder. It consists of output as 8 down to 0, so you have to declare it as in the square brackets d width down to 0, and for the input ports you have to declare as d width minus 1 down to 0. I think this is clear. Okay, the parameter d width is equal to 8 is a globally declared, so that if we does not change the parameter d width, it will consider it as 8 during instantiation. So there is no need to write all the seven half adders. It is simple if you write like this for all the 7 half adders. Let's look at what happens, what is the code for the instantiation. So similarly, module name, and the inputs and output ports, and the port declarations. Up to I think this is clear. And one thing should be noted, that the module name and the saved file should be of the same name. Okay, let's look what happens during instantiation. So the instantiation command, the instantiation syntax is, I am writing here, module name which is to be used, and instantiation name, and in brackets you have to write dot and their inputs, and to which it is assigned should be in the brackets. Suppose it x something input 1, and internal connection 1, so on. If there are n inputs, you have to declare for all the n inputs like this. Okay, this is the simple this is some syntax of the instantiation. So we have used adder under 2 input as the module name previously. I will show you simultaneously. This is the module name adder under 2 input which you have declared for the off adder. So module name and instantiation name, in the brackets we have declared it as inputs as x, y and o. So we have .x, .y, .o, and in brackets the internal connections to which it has to be made. Let us look. The inputs for this off adder are connected to A and B, and the output is connected some internal connection which has to be connected to the off adder file. So and A and B I have connected, and the output is somewhat adder 1 output. Similarly for these first 4, these 4 half adders, the same case where the inputs are connected to C, D, E, F, G, H, one after the other. So in the off adder 2 you have connected C, D, off adder 3 you have connected E, F, and off adder 4 you have connected G and H, and the internal connections are these respective are adder 1 out, adder 2 out, and adder 3 out, and adder 4 out, and you have to declare the wire connection as 8 down to 0, as these two inputs for this are 7 down to 0. So we have you have declared any parameter here, so it take a predefined parameter d width is equal to 8. So it doesn't change the d width value. It take d width as 8 itself in these first 4 cases. Okay, right? Now for the next two inputs, for the off adder 5, the inputs for it are 8 down to 0 and the output is 9 down to 0. In the adder under 2 input I, we have chosen a d with value which is of the order of output, that is for the first four we have output is 8 down to 0, so we have to declare d width as 8. For the next two, the d width is the output for the output is 9 down to 0, so we have to declare a d width value as 9, and the format for it is format of declaring d width, the changing parameter is def param, def param, def param, the instantiation name to which it has to be applied. So our def param name, def param adder 5 under instant dot d width is equal to 9. So for adder 5 under instantaneous module, it will apply this this parameter as 9, d width is equal to 9. So similar and the syntax for the instantiation is similar. Just for the parameter you have to use this command def param adder 5 under instantiation dot d width is equal to 9. For best practice, if you apply for these 4 also, it will be useful, and nothing will be happened if you use 8 here. In these first 4 cases, d width is equal def param adder 1 under instant and adder 2 under instant dot def param is d width is equal to 8. As if you doesn't declare, it will take a what you have declared a predefined value. So adder under 2 input, adder 5 instantaneous, and the inputs and outputs to which it has to be connected. For the adder 5 input, it will connected to adder 1 out and adder 2 out as inputs. So adder 1 out and adder 2 as 2 inputs, and adder 5 out is the another output, internal connection. So I have to declare internal connection here. Okay, similarly for the adder 6, the same as adder 5, d width is equal to 9 you have to declare by using def param space instantiation name dot d width is equal to name, the parameter which you have already declared. Now for the last off adder, here the output for the whole module is 10 down to 0, so I have to declare def param is equal d width is equal to 10. So the syntax for this declaration is def param adder 7 under instant dot d width is equal to 10, and this command is similar to that above all and end module. Okay, and the compilation and the test bench commands and the compilation simulation using model sim will be discussed in the next